Hello viewers, in today's class we are going to solve a very important problem related to definite integrals involving greatest integer function, right? So here we have to solve this integral that is from 0 to 2, and we have greatest integer of 3x over x plus 1, right? So let us first call this integral as I, right? Now here in order to solve this important integral, we have to make use of the method of uh, substitution, right? And viewers, the method of substitution is a powerful method to solve integration, right? So now here what we will do, we'll take t is equal to 3x over x plus 1, right? So this whole expression which is inside this bracket, the bracket denotes the greatest integer function, is taken as t, right? So it means we are changing the variable x to t, and here x varies from 0 to 2, right? So now here t is equal to 3x over x plus 1, and let us solve this equation for t, right? So we have t times x plus 1 is equal to 3x, and here we have tx plus t is equal to 3x, and we can write tx minus 3x is equal to minus t, and x is t minus 3, and here we have minus t, and x is t over 3 minus t, right? So now we have x in terms of t, right? And now we'll find out the derivative of x with respect to t. So dx over dt can be written as, here we have the quotient of two functions in t. So we'll make use of the quotient rule for differentiation. So here we have 3 minus t, then the derivative of t, and then we have t, then derivative of 3 minus t, and divided by 3 minus t square, right? So now dx over dt is equal to 3 minus t, and here we have 1, here we have t, and here we have minus 1, right? And this is 3 minus t square. So dx over dt is equal to 3 minus t, and here we have plus t, and here we have 3 minus t whole square. This t and this t get cancelled, so we have 3 over 3 minus t square, right? So now dx can be written as 3 dt over 3 minus t square, right? So now we have this relation, t is equal to 3x over x plus 1, x is equal to t over 3 minus t, and dx is equal to 3 dt over 3 minus t square, right? And now let us change the limits accordingly. So when x is 0, and here we have x is 0, so t is 3 times 0 over 0 plus 1, that is simply 0. And when x is 2, then t is 3 to the 6 here, and we have 2 plus 1, so we have 6 over 3, 2 plus 1 3, so we have 2, right? So when x varies from 0 to 2, t also varies from 0 to 2, right? So now we can write this integral I as 0 to 2, right? Now t varies from 0 to 2, and for 3x over x plus 1 we have greatest integer t, and for dx we can write 3 dt over 3 minus t square, right? And now we can take 3 outside the integral. We have 0 to t 2, and here we have greatest integer t divided by 3 minus t square and dt, right? Okay, so now here we see that t varies from 0 to 2, right? So here we have t is equal to 0, here we have t is equal to 2, and between 0 and 2 we have the integer 1, right? So what we will do, we'll split our integral from 0 to 1 and 1 to 2, right? So now I can be written as 3 times. Here this integral can be written as a sum of two integrals, that is I1 and I2, right? So I1 is from 0 to 1, I2 is from 1 to 2. So we can write 3, and I1 is from 0 to 1, greatest integer t over 3 minus t square, then we have dt plus 1 to 2 and greatest integer t over 3 minus t square, and here we have dt, right? Okay, so now we have to make use of the definition of greatest integer function, and when t varies from 0 to 1, that is t varies from 0 to 1, right? So when t lies between 0 and 1, then the value of greatest integer t is 0, and when t varies from 1 to 2, then the value of greatest integer t is equal to 1, right? So here we have used the definition of greatest integer function. So now it takes the form 3, and here we have 0 to 1, and for this greatest integer t we have 0, so we have 0 over 3 minus t square dt, plus here we have 1 to 2, and we have here the value of greatest integer t as 1, so we have 1 over 3 minus t square dt, right? So now the value of this integral is 0, because here we have 0, so now we can write 3, and this integral disappears, so we have 1 to 2 and dt over 3 minus t square, right? Okay, so now we have to find out the value of this integral, right? So for this what we will do, we'll again make use of the method of substitution, right? So we can take u is equal to 3 minus t, so du is equal to minus dt minus du is equal to dt, and to change the limits, when t is 1, then the value of u is 3 minus 1, that is 2, right? And when t is 2, then the value of u is 3 minus 2, that is 1, right? So now this integral I, it becomes 3 times we have, when t varies from 1 to 2, u varies from 2 to 1, so here we have 2 to 1, and for dt we have minus du, and here we have u square, right? So now we can write this integral as 3 times, and we can interchange the limits, so 1 to 2 and du over u square, because here we have the negative sign, and we know that a to b f of x dx is equal to negative of b to a f of x dx, right? So this negative sign disappears when we interchange the limits. So now we have 3 times the integral of 1 over u square is minus 1 over u, and the limits are from 1 to 2. We can take negative sign outside, so we have minus 3 1 over u, and limits are from 1 to 2. Now we have minus 3, and we can substitute the limits and we'll take the difference, right? So 1 over 2 minus 1 over 1, so we have minus 3 times minus half, because half minus 1 is minus half, and this is minus minus plus, so we have plus 3 over 2, that is 1.5, right? So viewers, the value of this integral is equal to 3 over 2, or we can write it as 1.5, right? So this is how we solve this important and conceptual problem related to definite integrals involving greatest integer function.